Hi, I'm James McElvenney, and you're listening to the History and Philosophy of the Language Sciences podcast, online at hi-fi-lang-sci.net. There you can find links and references to all the literature we discuss. Today we're talking to Ryan Nefdt, who's Professor of Philosophy at the University of Cape Town. Among Ryan's interests is the philosophy of linguistics, a topic that he's written about extensively in a number of papers and books. Some of his chief publications in this area are listed on the podcast webpage. So in this interview, we're going to discuss linguistic relativity from the perspective of the philosophy of linguistics. With his co-author, Jeff Pelletier, Ryan has recently published a short monograph covering the history of linguistic relativity and some of the main philosophical problems it presents. Specifically, Ryan develops in this book an interesting argument about what light LLMs, that is, large language models, might cast on the problem of linguistic relativity. So to get us started, could you sketch for us what linguistic relativity is all about?
Thank you so much, James. Thanks for that generous intro. Yeah, so linguistic relativity. Let me try to at least sketch what we were thinking about when we were talking about it in the book. In a synchronic viewpoint, it seems to be the thesis that language somehow constrains, shapes, or more strongly determines your cognitive horizons, your thinking. This comes in different strengths, as Jeff and I outline in the book. We opt for this sort of tripartite analysis between minor, medial, and grand, and the grand is sort of reserved for sci-fi context, even though I'm sure we're going to get to it with the LLM thing. Prince and Rienes go for habitual and ontological, and there are various other carvings of the concept. But basically, at the sort of synchronic level, it's the idea that your individual language you have shapes the way you see the world. At the diachronic level, it becomes even more complex because now the environment enters into it.
So how do you mean the environment enters into it from a diachronic perspective?
So in a way, the synchronic perspective, like in theoretical linguistics, is a bit of an idealization. To stop at a given time slice and say, this is the language faculty, or this is the conventions used by a linguistic community, it involves making a distortion of reality. The second you relax those constraints, as in the case of linguistic relativity, when you start asking questions like, well, how does language constrain, or why does a particular language constrain a cognitive process in a particular way, then the explanation becomes broadened. And then you get these, like, in some cases, mythological caricatures of like Inuit people and Yupik languages having myriad words for snow, sometimes thousands. And there the idea is that the language has the environment has influenced the linguistic community. It's made certain things salient or absent in that community. The language then encodes those environmental factors, and that gets passed on in the generation. So looking at it at a longer time scale then complicates the picture. And now linguistic relativity is also a thesis about how the environment or culture shapes language, which in turn shapes our sort of cognition. Somehow the language, or the life form of the language, to be a bit Wittgensteinian, is necessary to sort of appreciate that worldview or that viewpoint. And moving, as you could translate, but it's always going to be inadequate. So the Inuits leaving to a more tropical climes would not only lose the snow vocabulary, but they would lose a part of their cognition in that process.
Okay, but what exactly is the cognition? And is it just a matter of words, like a vocabulary? I mean, the examples you've given so far are vocabulary.
Right. So in the vocabulary cases, that's why I sort of assigned the Inuit case to sort of mythology. I know Jeff Pullum has written the famous, Great Eskimo Vocabulary Hoax, which rides on some debunking arguments from the anthropological literature that started out with maybe amplifications of what Worf had to say, and the media kind of took those ideas and put them in the sensationalist camp, because it's a little bit more interesting to think that people from different places that we consider exotic somehow think differently or something like that. I think in the most interesting and plausible cases of linguistic relativity, if such things exist. It's actually more syntax than lexical. I think the interesting cases come in with things like the claims that Mandarin, for instance, cannot express subjunctive mood. So that's a constraint on counterfactuality. So the culture doesn't incorporate this cognitive mechanism that we seem to think is quite natural in certain other languages of creating these counterfactuals. Philosophy certainly has run with the idea that counterfactuality is essential for the practice. And here's a language that presumably the structures of that language prohibit comfort with the subjunctive mood and therefore the sort of cognitive capacity that aligns with it.
So would you say that a Chinese philosopher or a monolingual Chinese philosopher can't deal with the concept of counterfactuality?
So I think here, and this is why the concept of linguistic relativity is so interesting, because it just touches on so many interdisciplinary questions. And one of the most interesting ones that I discovered is the question of replication in psychological research. A lot of the initial experiments that have delved into these kinds of differences, gender on nominal gender, sort of grammatical gender, in particular comparative classes, all of these kinds of supposed cases of linguistic relativity have been actually very hard to replicate. And this is a problem that I think besets a particular kind of cognitive psychology. So I'm more skeptical that these examples unearth some sort of deep cognitive divide. And I think that there are many mechanisms that Mandarin Chinese can use to have a very similar kind of mechanism to the subjunctive mood, even if it's not identified in the particular kind of way. I mean, Martin Haspel methods is often a useful guide for me. There's a sort of linguistic bias that comes with the language that you're trained in and the language that you feel most comfortable in. And English has, of course, dominated the linguistic landscape to a large extent. So if you have a very specific language specific category of subjunctive mood, and now you sort of export that and go looking for that in other linguistic environments, it might turn out that you don't find anything that looks exactly like that because there is no universal category. But that doesn't mean that the cognitive mechanism hasn't been exemplified or instantiated in a different kind of construction. So in that sense, I don't think that subjunctivity or counterfactuality is lacking from a Chinese philosopher's innate vocabulary.
So, but I mean, subjunctive mood is a linguistic category, right? It's a grammatical category. So what would be the cognitive correlate of it? Or to put it another way, is it possible to say that there's a cognitive correlate that exists independently of the grammatical notion of subjunctive that aligns with it?
Daniel Dennett had this view that language is the most efficient compression of human thought and reasoning. And I think in that sense, certain kinds of abilities that humans have is instantiated in language, but could be described independently of it. So take counterfactuality, for instance. I think if I had to speculate, I would say that it's an offshoot of the fact that we're not stimulus dependent in the way that many other organisms are. So whatever the communicative or symbolic representation, if you follow Derek Bickerton and his description of sort of bee language that has some sort of displacement and symbolic representation, it's still stimulus dependent. It's still based on this is the environment, this is the distance between the food source and the direction in terms of the sun. With human expression, we seem to be able to move beyond that. Now, it's a question whether it's language that makes that possible, in which case these questions open up again. But my sense is that if we want to describe it as a cognitive ability, it's more about this niche we've constructed for ourselves in which we can talk about things that don't happen in our immediate environment, could happen in a possible world that isn't ours. And the fact that our minds can do that is expressed in different ways in different languages.
Okay. So, I mean, how could you test this in a psychological experiment, or how have people tested it?
So that's the trick, exactly how to make this a testable hypothesis. Because it's not just a sort of grand philosophical theory. It's not an anthropological claim completely about like words for snow or things like that. In the early 2000s, moving slightly beyond, there were a flurry of experiments aimed at exactly identifying these sort of behavioral differences in communities of speakers. So, for instance, if you take something like coordinate encoding, grammatical coordinate encoding. So English has this relative structure. So something's to the left of something else. You move to the right when you're describing directions. Certain other languages might encode a more like GPS kind of abstract notion of like pure direction, northwest of a particular landmark or something like that. And that seems to then suggest that in certain environments where the particular syntactic construction or vocabulary might be more useful, you'd expect that speakers of that language would be able to identify things faster. And I think that's how the psychological experiments have worked, because obviously you have people in a sort of controlled environment, and you often are checking response rates on clicking for things. So whether it's Russian or Greek speakers being able to identify a different hue of blue, presumably that's going to be a behavioral difference from the English speaker who doesn't have to make that distinction when they're using the category.
So, to come to the main topic that we foreshadowed there in the intro, how does so-called artificial intelligence enter the picture? So what are some of the philosophical problems that have been raised in connection with artificial intelligence or AI?
So the LLM, I'll put that to the side for a moment, the question of LLMs, because that's specifically about natural language processing, where it's very obvious that the task is to try to reproduce language comprehension and production. But what's fascinating is that traditional AI, sort of from the time of Turing, had this linguistic focus. Language was always a conduit to intelligence. If you think of the original Turing test, sort of this investigator put in the scenario where they have to distinguish between a human interlocutor and an AI system purely based on text, that's assuming that language is some sort of conduit to intelligence and cognition in some way. So language has always been a very central tool, at least, to understanding the notion of intelligence, and many psychological tests are actually tests about language development. And I think when artificial intelligence emerged, the question was then, well, what's the holy grail here? Understanding of language. And traditional symbolic AI was much more logic-based. It was almost in the structure of a theorem prover. You have your axioms, which are like explicitly coded rules. In the linguistic case, you could think of like phrase structure rules. These are things you can encode, they're proof theoretic, they have a form. And then you have rules of inference that manipulate those symbols and give you new knowledge, presumably, even though it's deductive, so it's sort of contained in what you have before. And in that way, you sort of mimic the particular style which people for many, many years thought was the essential component of intelligence, reasoning. And reasoning through language was our clearest mechanism to do that. So our traditional artificial intelligence was very interested in finding ways to automate that process. And in philosophy, at least with Searle in the 1980s, this concept was challenged, that there was any sort of true understanding underlying the performance of these kinds of symbolic systems. Searle had the famous Chinese room experiment, in a way mimicking the structure of the Turing test, but suggesting, well, let's imagine this individual put in a room, they're given symbols that they presumably can't understand in an immediate sense, but they've got a rule book, they've got a manual that gives them all the rules for taking these symbols and changing them into other sequences or strings of symbols, and then sending it through the chute on the outside. Now, unbeknownst to the Searle or the person inside of this room, they are in a mall in China somewhere, and the people in the mall are sending questions into a slot. These questions are then being interpreted by the system, and answers are produced on the other side. And Searle's point was that the person in the room doesn't understand this language, doesn't understand Mandarin, doesn't understand Cantonese. But this is exactly what an AI system, a symbolic processing system, is doing. It's all syntax. It doesn't have access to semantics. And the best we can hope for is what he considered to be sort of weak AI. It's a facsimile of true intelligence and understanding, and without some sort of intentionality, which is a very specific term for philosophers, which means something like a direction towards an object, grounding relation to a certain extent. No AI system built on these principles will be able to achieve understanding. And again, from our perspective of linguistic relativity, what he means here by the example is linguistic understanding, understanding that language. So those are some of the sort of traditional worries with what's called by drivers good old-fashioned AI, GoFi. But it's a tricky one. The founder of artificial intelligence, or at least the person who coined the term artificial intelligence, because before that it was, I think the term was computer simulation. And people often speculate, would we be having these deep debates about consciousness and cognition if it was just called computer simulation as opposed to artificial intelligence? So John McCarthy dubbed the field artificial intelligence in 1956 at a conference in Dartmouth. And even some of the people present weren't very happy with the term. But he also described this notion of the AI effect. And it's still quite prominent in computer science now. It's the idea that once there is success on a particular task that we thought was cognitive before, it's no longer AI, and it's just like a run-of-the-mill computer program doing its job. So there's a little bit of like a shifting of goalposts that people worry about with the kind of Searlean arguments as well.
And how do LLMs differ from traditional AI?
So what some people don't realize, they think that, at least some of the views I've seen, is that there's this like complete bifurcation or opposition between traditional symbolic AI and large language models and neural networks. And in a way, that's true just based on the sort of mathematics behind these systems. But in another way, they were both exemplars of a computational theory of mind, of the idea that a good analogy for human cognition is a computer. And symbolic AI went one direction with that, sort of proof theoretic, logical. And connectionist networks, from which we sort of get the underlying architecture of modern AI and large language models, approached it from a different angle, an idealization of the information processing of a human or an animal neuron, and dendritic and synaptic connections between them, sort of activation patterns that go through pathways in our brains. And that idea, since 1948, with McCullen and Pitts, was used to channel this possibility of maintaining the computational theory of mind and the computational view, but through a different kind of mechanism that isn't this explicit encoding. And LLMs are the sort of latest tradition in natural language processing that come from a particular kind of methodology known as machine learning. With machine learning tasks, you take a data set, you split it in half, you say, okay, I'm going to train on this half of it, and I'm going to test on the rest. And I use these artificial neural networks, these particular kinds of structures to find patterns in that data, like functional relationships between the data through weighted connections, which basically say when the connection is stronger and weaker. And then once I've done that process, which also involves a very complex notion that people have won Nobel Prizes for recently, called backpropagation, which is like the chain rule of calculus applied to error minimization. So these things, and this is another distinction from GoFi and symbolic processing, they don't necessarily have like explicit rules encoded. It's very unsupervised. It's very much finding connections and then iteratively and incrementally changing the weights according to the desired result, a comparison between the desired output and an initial random pass, initial random sort of feed forward of the information. So you can understand why some people are trepidatious about saying that there's understanding here, because it's like teaching one of your students who just keeps guessing until they get to the right answer. You might worry, like, even if they arrive at it, that they haven't done that through sort of a proper cognitive pensive process of really thinking about the ideas. But then once you've got that structure, you now apply it to the test data to see, has true generalization actually occurred here? Can this system handle novel data? And that's where we get large language models that are a particular system trained on what's called next word prediction or next token prediction.
And what does this tell us about linguistic relativity then?
What we noticed when reviewing a lot of this literature is that the big debate, in a way, kind of a resurrection of Searle's Chinese room argument worries, especially from Emily Bender, who's quite a strong critic of the hype, certainly, that's associated with modern AI and large language models. She wrote a paper in 2020 that got a lot of traction with Alexander Kohler. And there they had their own thought experiment. It wasn't Chinese room this time. It was a desert island where this statistical big data-y pattern matching octopus intercepts a telegraphed communication between two marooned islanders. And the argument was similar in that these systems are trained purely on form and not meaning. And by meaning, we think of like communicative intent, grounding reference. Philosophers of language certainly have used that concept to explain language quite robustly, and that's quite a dominant position. And it doesn't seem like when an LLM is doing massive sort of statistical analysis and pattern matching on a particular representation of text. Remember, these things aren't fed actual language. They fed a tokenized version of language, and tokenization is a process of compressing data, and then the representation that they're appreciating is a vector matrix of numbers, series of numbers that map onto collocational data in the spirit of the distributional hypothesis of computational linguistics. So the worry there that has resurfaced is that there's just no understanding in the system. It looks like it's understanding. Many people are interacting with these things linguistically every single day, multiple times a day. It's become quite pervasive. But it's an impression of understanding. It's a mimicry. It's a stochastic parrot. It doesn't have actual real cognition or understanding. And Jeff and I started thinking about this claim and thinking, well, what is at stake here, really? And in a sense, it's a way of appreciating grand relativism or linguistic determinism outside of the context of sci-fi, because we don't need Orwell or Newspeak or the heptapod language of the movie Arrival based on the short story to appreciate that this is a system that seems more equipped than any system that we've seen before, artificial or natural besides human beings, to appreciate the complexity of natural language, at least syntax. One remarkable thing in the spirit of the AI effect, I think, that I spoke about earlier with John McCarthy, it's actually quite remarkable that these things are so syntactically competent. Many linguists didn't think this was possible. It just, this was a holy grail in computational linguistics. Generative linguists dismissed a lot of this kind of approach. And right now we do have artificial systems that seem to be able to string seamless language structures together, seemingly answer our questions, summarize texts in reasonable ways, notwithstanding things like hallucination and other worries. So we use this as a thought experiment to think, well, what kind of process of viewing the world, representing the world, what worldview can be extracted from a purely linguistic agent, which an LLM is? And in the sense that Dennett and others like Daniel Rothschild recently have argued that language is this compression of our thoughts and our worldviews, maybe indirectly. LLMs seem to have access to that. And so they're processing pure language, and then if they build a world model or a model of the data, that actually gives us an interesting avenue to investigate linguistic relativity, the question of how language affects thought or processing. These systems are, in some cases, even better subjects than humans might be.
So have you thought about what exact tests you would do, like if you were to conduct experiments?
So some experiments lend themselves to the larger question of how culture, what I deemed at the beginning the diachronic question, sort of how the culture and environment can be infused and encoded in language. So now we get these tests that this is how I would imagine constructing this kind of question based on translation. So you take a language that doesn't have a particular grammatical structure, even something like gender. And so English doesn't encode gender in at least the nominal morphology, but some other languages like Spanish do. So now you watch what happens when certain kinds of concepts are translated. For instance, what people have noticed is that you do encounter a gender bias. This was Boroditsky's et al.'s claim in the early 2000s that they used Spanish and German speakers, and they looked at nouns that differed in gender, and they said things like, well, if in German a bridge is masculine and it's in Spanish it's feminine, then they used bilingual speakers, so people who spoke English as the sort of base language, and they tested what impressions, what kind of adjectives they might use to describe these concepts, and they, according to their unfortunately not very well replicated studies, things like soft and beautiful and and those kinds of concepts were attributed to the feminine gendered nouns. Now, from this perspective, you can see that happening if you do machine translation and you force a translation that requires a gender to be attached to a genderless term like doctor or nurse or something, and then you see what happens when you translate it from these languages or languages that have neuter nouns for these concepts. And what does seem to happen is a reflection on culture. Doctors tend to be male, even translators, teachers, even in contexts, surprisingly here, and this might be the influence of sort of internet culture, even in cases where the distribution of the particular occupation is actually not male dominated, you'll still see concepts that are associated with positive roles in society being associated with males. So that I think can give us some access to how this complex interaction between culture, language, and cognition might be approached from a computational perspective.
Yeah, okay. But I mean, doctors and nurses, as you said yourself, are the names of occupations that are performed by people who have a natural gender, whereas, that's different from, say, a bridge, which is a thing that doesn't have a natural gender.
Right.
So
And
that's
then
not
you might
really.
worry that the experiments have to take on a different structure, because the grounding issue and the Chinese rooms and the octopi are going to be a problem, because presumably an LLM doesn't have any concept of sort of beauty or anything like that. They might be able to use language in a similar kind of way based on statistical patterns and probability distributions, but that wouldn't tell us much about cognition, I think.
I mean, maybe it's just telling us about the biases built into the corpus that the LLM has been trained on.
Certainly. But in a more grand style, what's surfaced recently, especially from a team of researchers at MIT, is this notion of Platonic representation hypothesis, which is fascinating from a philosophical perspective. And the idea is basically this: given the way in which AI systems are trained to look for, so they scaled up to massive degrees, and then they look for sometimes the simplest solutions. So that's what's called sort of a strong inductive bias, although in most of the AI systems, they don't actually have strong inductive biases, which is a big worry for Chomskyians about why these things are not relevant in their opinion, because they don't have the strong biases that humans have, the innate structure. So they're just kind of pure empirical machines. But the Platonic representation hypothesis has actually claimed that we're noticing LLMs of various sorts and vision models and other AI systems actually converging on a particular representation of reality based on the sort of constraints of their training and their architectures, which is, if you still following the thread here, sounds a lot like linguistic relativity. They're being trained on a particular, especially in this case, linguistic data set, and they're converging on a model of what the world looks like in a computer vision setting. And that is at least tantalizing from the perspective of grand relativism, the idea that language would project a particular view of the world that even these AI systems that don't necessarily interact directly with the world would then have, sort of in the sense of Plato's cave, sort of shadows on the wall. Might not be the actual reality, but it's what our data reflects about that actual reality.
So how do you measure that they're converging on the same model of the world?
So that's an interesting question, and some people have questioned the methodology with relation to exactly how you would measure that there's a sort of unified worldview. One suggestion is, I mean, it's all sort of vector space semantic relationships between different kinds of representations that's found in the data. So in that sense, you would see that an LLM is maybe projecting or describing a scenario that would be then continuously described in visual model with a different medium. So it's sort of like the idea that there's a correspondence given the training, even though they are different training sets, but given the nature of the training, given the nature of this AI system's cognition as a neural network, transformer-based neural network. And so it's tricky to measure exactly what would count as the same representation, but I think it's generally just looking at the output and what that output entails about a particular scenario.
I think that's probably all the questions I wanted to ask you. Is there anything else you wanted to say?
Returning sort of to the philosophy of linguistics of it all, I think
Hmm.
there's quite a bit that makes me excited about the future. I think when we're talking about AI and LLM, sometimes, especially in theoretical linguistics and cognitive science, it's easy to become pessimistic. And it's easy to do that because the hype is so profound that you feel like you have to like confront that hype, and then maybe an eliminativist position is suggested after that. But I think that from the perspective of empirical approaches to theoretical linguistic claims, this is a new territory. So take this recent debate between Andrea Moro and Chomsky and others on the concept of an impossible grammar. That's something that's well established in sort of the canon of generative linguistics. If natural language, if humans acquire and cognize a natural language as a hierarchical structure, then there are certain constraints that come with that. So for instance, we wouldn't process languages that have linear orderings. If every third word in a string has to create a negation, you have to put a knot in every third word, and that's the sort of numerical representation that's doing work there, or the statistical sort of frequency analysis. That's not how humans seem to learn according to this well-known established approach. You've got poverty of stimulus arguments that suggest that human beings learn in a very constrained time period when a lot of other cognitive mechanisms haven't been fully developed, but they master their languages. And I think LLMs are interesting test cases for this. So for instance, a team at Stanford, including Chris Potts and I think the team was led by Kalini, they tested this hypothesis with transformer-based grammars. They tested whether or not LLMs have a preference for hierarchically structured linguistic data. And they created this continuum of impossible grammars, starting from what we think humans are, the way humans are processing, to absolutely sort of like randomized, shuffled strings. And their research suggested, contra a team at Bristol who used a slightly older architecture, recurrent neural networks, and they confirmed the Chomskyan hypothesis that's harder for humans and LLMs can learn any impossible grammar. And the Stanford team challenged this hypothesis by suggesting that no, actually, they struggle and they show a clear preference. And myself and a colleague, Emmanuel Chemla, entered the debate by worrying, well, of course they would share preference because they trained on human language, right? So it's not, that bias might just come out from the nature of their training. So these kinds of things I think are very fascinating. They give new life to a lot of stagnant debates that were very hard to move outside of the theoretical domain and very hard to test. So that I think is a silver lining with the caveat, because I do agree with many people like Emily Bender who are worried about how these systems are going to be incorporated into theoretical discussions. Maybe linguistic relativity can help us take a very abstruse concept that seems unshakable in many people's minds and give us a little bit more clarity in a very artificial, contrived setting.
Great. Well, thank you very much for answering those questions.
Thank you so much for the lively and interesting conversation.